Alright, this is just right off the web. They're pictures off of Google now. You'll be able to see who put the picture up as I go through these quickly. But I received something from a fellow named Pete the other day. Nice guy. He follows what I've been playing around with, and he fully understands what's going on here. He seems to be interested in things, and sent me this post about Devil's Postpile, which I was not aware of. So I looked at it, and wow, this got this smoking guns everywhere. It's just incredible what is in this particular park here. Every detail that you're looking for. These little barrels, these are all the little barrels of the muscle fiber. And these little wavy parts are where the tendons turn in from their mineralized, really spiky tendinous material, and then they start turning into these barrels, and this is all eroded away. This is a gigantic, gigantic creature. You get these different color formations, and I have them too, and they're everywhere. And they are caused by the difference between the white and the yellow and the red muscle tissue and tendinous and the fascia as well. And there'll be blood investments in here. In a lot of places you'll be able to find blood. And the architecture of these things this is exactly how tendons invest. They tag in at the base, then they come up to where the muscle fiber starts, and the muscle fiber is the weak part, and that's what erodes. These are the tendinous materials, and there's a reason that they shape like this too. And I go through all this in the video. There's just guns smoking everywhere. And I thank you, Orwell. Okay, this is from maps.universityofomaha.edu. Now, when I say I look for a smoking gun, this is like sizzling, man. This thing is combusting. That is a tendon assembly. Absolutely, no question about it. This is the way tendons invest into into bone, sometimes in an angular fashion like this. There's the slightest bit of waviness you'll see in these tendons, because there's like a 1% movement of tendons, so they're just don't snap. Now you look up here, the tendon turns into the muscle fiber, and there it is right there. That's exactly what muscles do. Exactly. And around this will be plagioclase tendon investments, antithesis points, whatever you want to call them. And I have all of the architecture. I'll show you how they invest and how they're built, and the whole shooting match. Alright, there's another shot of this, and this is going to be the antithesis point at the bottom. I know it sounds insane, but that is like one single muscle emplacement. I'm telling you, it's crazy. But up at the top, those are the muscle fibers are starting to take off, and it's to turn into a bulbous thing at the top, like a sausage, just like a muscle. Alright, this is from dev.biologist.org. Totally easy to understand. Tendon emplacements. Across here is basically where the bone would be. Now, as you grow, it begins to grow, minerals begin to get in place. Plagioclases and mineral concentrations show up here, and then they turn spiky as like crazy. And this is the tendon strap that goes out, and then it becomes the muscle tissue. This is literally a piece of muscle, and that is the fibers are in there. There's a little black elastins, everything. Now, you see, you see down here, identical same thing, and it broke off here. This part is missing from that thing that's sticking up. It's broken off right about here. That's this. You see it? It broke right off right at the edge. And what is sticking up will show the fibrous, these bundles sticking up, and it does, and they have these little barrel shapes. I'll show you that in a second. Alright, this is a piece of what's called limonite. And if you look closer, you're going to see the vein and the artery. Alright? The vein clamps off and keeps the dark stuff in there, and then it runs out when it gets exposed to things. And that ran out, and that's all this blood on the bottom ran out here. Now, the other side, I believe, is the artery. But anyway, whatever. It's one, there's two of them. Now, here's why I'm saying things crystallize. Now, over here, the blood has crystallized on the side. See that, Fawn? That's it right there. That's exactly. Now that we talked about geology, look at these little barrel things. I mean, you know, think about it. Now, not only that, look at this. You see these little things here? Those are the blood supplies that give this thing, that nurture this. Now, I found those too. All right, this is not close to the human body. It's identical. Identical. You see this? The colors, the striations, the type of the fibers. You're going to find that there's going to be blood supplies in here. Guaranteed there's going to be blood supplies. I believe these are going to be the areas. This is the transition from the extremely mineralized tendinous material to the fleshy material, and they break at this exact spot every time. And mine do too. And I've shown it before. I have a piece of red muscle that breaks exactly the same way. It has the white and the white and the red and the yellow and all the fascia and the whole thing identical. Not close, identical. You see those different colors? Nobody painted them or anything. The reason they're different colors like that is because it's exactly what happens in your tendons. They transition into muscles. You see these little wavy things here? That's exactly what a tendon does. Identical. You see the way they're fusing together? You see this? That didn't just happen by accident. That is identical. It's identical to what happens in tendons in our body. Or you can look it up in any textbook or about anatomy, and you'll see that the tendons have a wavy pattern to them, just a smidge. They're not like swish, 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 swish like this. They're just a smidge, and the reason is so that they don't just snap when they hit their extremity. But tendons are extremely strong. They're highly mineralized. All right, there is some current thinking that the fascia in the body may be the fiber optic network that controls every cell and all your muscles and literally everything that happens in your body, because it literally is one system, they found out, and it touches every single cell in your body, apparently. Now, this is what I'm told and what I think I see. Now, I've been studying this fascia because it is the protective agent in my mud fossils. And hold on one second. I have all right, here it is. Hold on, don't run away. This is the kind of stuff that is fascia. You see this fibrous network? I don't know if you can see how well you're going to see that, but that is actually like a fibers, and that's exactly what she's talking about in here. Now, this is a lung. It's been DNA tested. It's 100% human. It's old. That's the depression. It's a left lung. It's a depression of the heart. That's when the investment at the bottom, and that's the patterns they have in the lung. That's the investment at the top. The air